All right, today we're going to dive into a core DevOps skill, upgrading a Linux file system. We're going to walk through the whole process, step by step, taking a classic ext2 all the way up to a modern ext4. I'll show you every command you need to get it done safely and, without breaking anything.
So here's our game plan. We'll kick things off with a basic ext2 partition. Then we'll level it up to ext3 by adding something called a journal. From there, we'll modernize it to ext4. We'll even look at how to control that journal and then wrap everything up with some essential best practices. Let's get to it.
First things first, we need a baseline to work from. So we're going to create a partition and format it with ext2. You can kind of think of this as the granddaddy of modern Linux file systems. It totally works, but it's missing all the safety features we really take for granted today.
To get our ext2 file system up and running, we're just going to follow these 4 simple steps. We'll format it, make a directory to mount it on, actually mount it. And then the most important part, we'll double-check our work to make sure everything is exactly as we expect.
This is the command that does all the heavy lifting. mk2fs is the standard tool you'll use for creating these file systems. And here's the key. If you run it just like this, with no extra options, it defaults to creating a classic ext2 file system. And that means, importantly, no journal.
And here's the proof. After we mount it, we run the df command with the -ht flags. Just look at that type column. It says ex2 clear as day. Our starting point is now set.
Okay, now for our first major upgrade. We're converting this thing to ext3. The single biggest, most important change here is that we're adding a journal. And let me tell you, this is a massive leap forward when it comes to keeping your data safe.
So what exactly is a journal? Well, think of it like a to-do list for your hard drive. Before the system actually writes your data, it first jots down what it's about to do in this special log. So if your server suddenly loses power, when it boots back up, it just reads the journal to see what it was in the middle of doing. It can fix any problems in seconds. It is a critical safety net.
The conversion to ext3 is, you'll be happy to know, surprisingly easy. It's just 3 steps. But step 1 is the most critical of all. You absolutely must unmount the file system first. You can't change the engine while the car is running, right? After that, it's as simple as adding the journal and then verifying the change.
And this is the magic command. Tune2fs is a fantastic utility for tweaking file system parameters. That little -j flag simply tells it, hey, add a journal. Once you run this, you have instantly upgraded your ext2 partition into a full-blown ext3 file system.
And of course, we verify. This time, we'll use the blkid command, which is great for checking device attributes. And look at that, it now clearly reports the type as x3. Just like that, our file system has its safety net, and it's way more resilient against crashes or power failures.
All right, time for the final jump. We're going from xt3 to xt4. Now, this step is all about performance. xt4 brings in new structures on the disk itself that really speed up file access, especially for big files, and they make file system checks, so much faster.
Now, the command looks pretty similar, but the logic is a bit different. We're using tunefs again, but this time with the capital O flag to turn on a specific list of features. Extents, uninitbg, and dir index. These are really the core features that make ext4 what it is.
So let's quickly break down what we just turned on. Extents is a much smarter way to keep track of where file data is stored, which is a game changer for large files. Uninitbg lets the file system check utility, fsck, just skip over empty parts of the disk, which makes it way faster. And dir index helps you find files in really big directories much more quickly.
So we've enabled all these powerful new features, basically by flipping a switch. But the actual structure of our file system on the disk, well, that needs to be updated to match. This brings us to a step that is so critical you just cannot skip it. Any idea what it might be?
You have to run a file system check. The -f flag there forces a check even if the system thinks everything is fine. This command goes through and properly sets up all those new ext4 data structures we just enabled. Seriously, if you skip this step, you are asking for some major file system corruption down the line. Part of really mastering file systems is knowing how to manage their individual features. We just work to add that journal for safety. But there are some, let's say niche, situations where you might actually want to turn it off. So let's take a look at how you can toggle this feature. Check this out. The command to disable the journal is almost identical to the one that enables it. The secret is that tiny but powerful little caret symbol, the up caret, right before has journal. In this context, that caret basically acts as a not operator. It's telling Ubuntu to remove this feature from the file system.
Okay, and this is a really big warning. Just because you can turn off the journal, it absolutely does not mean you should. Removing it takes away that safety net we just created and puts your data at a huge risk if there's a crash. You should only ever do this for very specific, expert-level scenarios.
Wow, okay. We've gone through the entire upgrade path from ext2 all the way to ext4. So let's pull it all together now with a quick summary of the key commands and the most important best practices.
And here it is, your cheat sheet. Every important command from today's session all in one spot. From creating the file system to converting it and managing its features. This is definitely one to bookmark for a quick reference when you're working on your own systems.
And these are the golden rules. Seriously, think of this as your pre-flight checklist. Always unmount before you do anything. Always run that E2FCK after an ext4 conversion. Never, ever touch the extends feature on an active ext4 file system. And pro tip, use UUIDs in your fstep file. Following these will save you from some massive headaches, trust me.
This right here, this really gets to the heart of the matter. That journal is your #1 defense against data corruption. Unless you have a super specific, weird reason, like maybe it's a read-only system or you're doing some strange benchmark, that journal should always be on, period.
And that's it. We've just walked through a fundamental skill for any sysadmin, any DevOps engineer, taking an old file system and safely bringing it up to modern, high-performance standards. You now get the what, the how, and most importantly, the why. So the only real question left is, what are you going to build with this new skill?